everyone, I am Sharani. Welcome back to my channel. Today in this video, I am going to explain about the real numbers chapter. So, without late, let us start now. What are real numbers? What are real numbers? The combination of rational and irrational numbers. So, the combination of rational and irrational numbers are nothing but real numbers. So, what are irrational numbers and what are rational numbers? Rational numbers mean the numbers which can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Those numbers we call it as rational numbers, and irrational numbers mean the numbers which cannot write in the form of P by Q. Those numbers we call it as irrational numbers. So, rational numbers are represented by the letter Q and irrational numbers are represented by the letter S. So, the combination and real numbers are represented by the letter R. So, the combination of Q and S, both we call it as real numbers. So, the rational numbers means these are in the form of P by Q, but these are not in the form of P by Q. Where P by Q in this P and Q are integers. What are integers? Integers are nothing but positive numbers, negative numbers, and including 0, we call it as integers. So, in this positive numbers, all numbers are included. Those are all we call it as whole numbers. And natural numbers means from 1 to infinity, we call it as natural numbers, including 0 with the natural numbers. Those we call it as the whole numbers. And positive numbers, negative numbers, including 0, we call it as integers. Next, the numbers which can be written in the form of P by Q, those numbers we call it as rational numbers. The numbers which cannot be written in the form of P by Q, those numbers we call it as irrational numbers. That will, for example, here, example of irrational numbers, root 2, root 3, root 5, root 7, like that we can say. Here rational numbers, minus 2 by 3, examples of rational numbers, minus 2 by 3, plus 5 by 7, 0, 3, 5, or 27 by 2, any other number you can write. Either 0 also you can say that is the rational number, and 3 and 5, these are all the whole numbers. Every whole number we can say that those are rational numbers. Why? Because these numbers also we can write in the form of P by Q. 0 is a number, that also rational number. How can you say this is a rational number? Means suppose here 0 is there. 0 can be written as 0 by 2 or 0 by 1 or 0 by 100. Anything you can write. 0 by anything equal to 0. So, these whole numbers, any other whole number can be expressed in the form of P by Q. So, we can say that these are all whole numbers. Any other number, suppose 3 is a number. 3 means 3 by 1. By 1 only, division of 1, then only you will get the same number. So, you can say that this is also a rational number. 3 can be expressed as 3 by 1. So, this is in the form of P by Q. So, we can say that this is also a rational number. 3 by 1 is nothing but 3. For example, 25 is a number. 25 by 1, that equal to 25. Minus 3 is a number. Is it the rational number? Yes. How can you say? Minus 3 can be written as minus 3 by 1. Again you will get minus 3. So, these all numbers we call it as rational numbers. Whatever the numbers we cannot express in the form of P by Q, then those numbers we call it as irrational numbers. Examples of irrational number, that means simply you can remember that square root numbers, these are not the perfect square numbers. So, root 2 is not the perfect square number. Suppose root 4 is a, can you say is it the irrational number? No. Why? Because here 4 is a perfect square number. Square root of 4 equal to 2 is the answer. That means 2 square equal to 4. Square root of 4 equal to 2 is the answer. Again 2 is a whole number. 2 can be expressed as 2 by 1. Then you will get 2. So this is in the form of P by Q. So this we cannot say that this is the irrational number. So this number is the rational number. Whatever the numbers are not the perfect square numbers, those numbers we can say that irrational numbers. Those are all that square root terms, square root 2, square root 3, square root 5, square root 7, again square root 9 you cannot say. Square root 8 also you can say, like that. These are the irrational numbers. Next topic in this. In this first theorem, what are the important contents? What are the important topics in the real numbers? In this first one is division algorithm. Division algorithm. What is division algorithm? Division algorithm or Euclid's division algorithm, both are same. Euclid's division algorithm or Euclid's division algorithm, both are same. What is division algorithm? We know the division already, as we know here. For example, here division 25 by 3 equal to how much? You know that how to divide this number. So 25 by 3 can be written as here in this 8 3 jar 24 and remainder is 1. Then how can you say that this number, these two multiplication and addition of this one is nothing but dividend rule. This is that one as a division algorithm here. What is a division algorithm? Here 25 is the dividend value, dividend, and this one is divisor. So what is a division algorithm here? Dividend equal to divisor into this one is quotient, into quotient plus whatever the balance you are getting, that we call it as a remainder. That is remainder, that equal to plus remainder. Dividend equal to divisor into quotient plus remainder. This is the division algorithm. See, like that you can check it whether our division is correct or not. How can you say here? 3 8 24. 24 plus 1, that equal to 25. Are you getting this dividend value? Yes. Like this you can check it easily. Here I am writing here, see, 25 is a dividend. Here divisor is 3. Multiplication of quotient is 8 plus remainder is 1. So 3 8 24 plus 1, that equal to 25. Whenever you are getting here LHS equal to RHS, then you can say that our division sum is correct. What you done, that is correct. So like this we can check it whether our division problem is correct or not. So this we call it as a division algorithm. This is a formula. This is a formula. Dividend equal to divisor into quotient plus remainder is a formula. Here also, what is division algorithm or Euclid's division algorithm? Both are same. Here A equal to BQ plus R. This is the division algorithm. Here A equal to BQ plus R is the division algorithm. Here A and B are given two positive integers, and where Q is the quotient and R is the remainder value. This is the division algorithm. So in this Euclid's division algorithm, where A equal to BQ plus R, here A and B are two given positive integers. Here to adjust two unique pair of integers Q and R, where Q is nothing but a quotient and r is nothing but remainder. Here the condition is remainder value is greater than or equal to 0 or less than b. This is the condition. So r is greater than or equal to 0 or less than b. That is the formula. Here a and b are two given positive integers. There exists unique pair of integers are q and r. Then that r condition is r value is greater than or equal to 0 or less than b value. Where here b is the divisor, that is divisor value, and r is the remainder value, and q is the quotient. And this Euclid's division algorithm, that is one of the technique to find out the HCF of the given numbers. To find out the HCF of the given number. So for example here 140. So these two are the two given numbers. Find the HCF of these two numbers. By using that Euclid's division algorithm, you can find out this HCF value easily. How can you find out? In between these two numbers, big number you have to assume as, let us assume a equal to 100 and b equal to 40. You have to consider like that. Next, here apply that is the Euclid's division algorithm according to the y. Division algorithm. A equal to BQ plus R, we know that. So A equal to directly 100 equal to BQ plus R, where B equal to 40, multiplication of where BQ is nothing but B into Q. So 40 into Q, Q is nothing but a quotient. So 40 it goes in 100 how many times, just you have to check it. 4 to the 80, that means 40 to the 80. So 80 plus remainder plus r is nothing but remainder. Remainder equal how much here? 100 minus 80, 20. Now again you have to consider here the big number. This value you have to consider as a, that equal to 40 equal to this number is b. So 20 into this 20 goes in 40 how many times? You have to check it. That is 2 times. 20 to the 40 equal you are getting. So remainder value equal to 0. So whatever the last divisor is there, that we call it as the HCF of the given numbers. Therefore HCF of 140 is 20 is the answer. Here till getting of remainder 0, you have to do like this. According to the division algorithm, like this you have to solve it. This is the procedure. This is one of the technique. Euclid's division algorithm is one of the technique to find out the HCF of the given numbers. So in this chapter, you can, by using this division algorithm, we can find out the HCF of the value given numbers. So what are composite numbers? The numbers it has more than 2 factors. Those numbers we call it as composite numbers. So all even numbers except 2, remaining all even numbers are composite numbers, as well as some odd numbers also you will get here. So for example here 6 is a number, 6 is an even number. What are the factors of composite numbers? Means 2, 3 and 6. 2 is divisible, as well as 3 is also divisible, again 6 is also divided. So 2, 3, 6, these 3 are the factors. So how many factors it has? 2, 3, 6 and 1 is a common factor to each and every number. So more than 2 factors it has. So we can say that these are composite numbers. So here what is the fundamental theorem of arithmetic means? Every composite number can be expressed as a product of prime numbers. For example here 35 is a number. This is also the composite number. This number can be expressed as the product of prime numbers. So by using prime factorization, you can find out the factors. 35 can be, it is divisible by 5 divides 35 in 7 times. So 5, 7. Again here you are getting odd number 7. That is also prime number. So 35 can be expressed as 5 into 7. So this is also product of prime number. 5 and 7 are prime numbers. So 35 can be expressed as the product of primes. Those prime numbers also unique pattern. So 5 into 7 and 1 is a common number. So here this is also a composite number. This already we have expressed in the form of product of the prime numbers. Right. Next one. Next topic is here finding of LCM and HCF by using prime factorization method. So here HCF and LCM, what is HCF value is product of the smallest power of each common prime factor of the numbers. Here each common prime factor of the following numbers, but LCM is a product of the greatest power of each prime factor of the numbers. And this is the difference here. Smallest power of each common prime factor. Here product of the greatest power of each prime factor of the numbers. This is the formula. So for example here, finding of LCM and HCF of the two given numbers by using prime factorization method. That is 12 and 15 is the numbers. This already we know that in the 6th class, 5th class, we know that, as we know that by using prime factorization method, how to find out the factors of the given numbers. Here, just see here, 12 is the even number. Even number means 2 divides. 2 divides 12 6 times. Again 2 3 times. Again 15 is the odd number. So 3 divisible. So 3 5 times. 3 5 are till getting a prime number you have to divide. So 12 can be written as 12 equal to 2 into 3. These 3 are the factors. 2 is multiplied by 2 times. So 2 square multiplication of 3 to the power of 1. Again 15 equal to 3 into 5. One time only. So 3 to the power of 1 into 5 to the power of 1. Here you have to check it. What is the HCF of 12 and 15 equal to? What is the value here? Product of the smallest power of here each common prime factor of the numbers. See, these two are the given numbers. Among these two numbers, only 2 numbers are there. So you can say that in between these 2 numbers, you have to check it which is the common prime factor. Here 3. That is the least power. 3 to the power of 1, 3 to the power of 1. That is the HCF value. So HCF equal to 3. And LCM now. LCM of 12 and 15 equal to, what is that here? Product of the greatest power of each prime factor of the following numbers. Greatest power, what is the greatest power here? 2 square. Again 3 to the power of 1. Again 5 to the power of 1. 5 to the power of 1, 3 to the power of 1 is nothing but 3 into 5. Where 2 square equal to 4, multiplication of 3 into 5. 4 3 is 12, 12 5 is 60. So LCM of 12 and 15 equal to 60. This is the answer. So by using this prime factorization method, you can find out that LCM and HCF of the given numbers. Thank you all. Once again, thank you. If you like this video, please like, share and subscribe my channel.